Sure. Okay, let's talk about more about division. Okay, because division is a bugaboo for people. And these are all things that you need to practice in the meantime. If we were in regular school, we would be doing lots of lessons on these. But I just am expecting you guys to watch them again and maybe make up your own examples, right? Again, for my students, I'm going to post some examples on Google Classroom, but you can lead a horse to water, but you can't make them drink, you know? So let's talk about the ways division is presented and what that means. So let's look at a couple of these. I wonder if I could just set this down. We're going to do this. Let's see if this is going to work. Oh, look at that. Hi. Okay, so first of all, this is something you'd see in like a recipe, right? In a cookbook. Like 3 parts out of 4 is what we mean, right? So if I divvied up a pie into 4 parts, right? What I mean is I want 1, 2, 3 of them, right? I don't want the whole thing. I want 3 parts out of 4. Now, look at that fancy move. This can still be written as a fraction, or excuse me, as a decimal. Every number can be put into our decimal system. And what's different remember, rational numbers ratio are fractions, which is ergo division, right? But decimal numbers, some of them can be put back into rational numbers, and some of them are irrational. Don't forget that, okay? Again, I know normally I would spend lots of time on this, but you just got to go back and find a lesson, all right? Because we are virtually learning, and you know that everyone's doing this because Wi-Fi crashes almost every day for everyone. I have not had a meeting where someone hasn't crashed out yet. Okay, so this is still a thing. And before, I'm just going to jump to the chase on some of this because I'm going to show you in a second. So a lot of you already know this. 3/4 out of 4 for $1 is how much? It's 75 cents. Which, by the way, I am the queen of writing upside down. That comes from a lifetime of tutoring and teaching. Okay, so this fraction bar, right? I personally like to write it straight up, 3 over. Hi. You will never see me write it this way. Never. Because I don't like it. I write it that way. Because it's more implicit in what's going on, especially in order of operations. But you'll see this written this way a lot in the world. Okay, lean back down. So here's another form. And we talked about this for a hot second yesterday. This thing right here, this is like saying number, right? Do you see this bar? That's that bar. So what this translates to, for the record, is the same as 6 over 2. You're welcome. All things go back to this. This bar means this is going to be going up here and that goes down there. Okay? Again, you will... Hi, peekaboo. You will never see me use this. Never. Because this gets confusing. But Heidi-ho. I will use it for examples, especially from generated worksheets, where I'll use it so we can, like, okay, whoa, what's going on? Like as a languagey thing. But as we get higher up into just the math and the algebra and algebra 2 and blah, 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 I'll never write it that way because it's a useless entity. But it's still a code we have to understand, right? What makes mathematics difficult for people is it's a code. It's a code of ideas. Reading is a code of sounds, right? It is. It's a code of reading is a code of sounds to symbols, right? Actions, nouns, descriptions, right? Those are all the things that are encoded in our words. Encoded in math is size, volume, idea, it quantifies really big things that you skip out on other stuff. So that's why it sometimes is difficult. But the writing of division are code. All right, so back to it. Now, these two versions, you can kind of know what this is. So you have this, you could say, I have 6 things, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and I'm going to batch them in 2s. 1, 2, 3, and I get 3. Okay? That's how you could think of dividing that up. But the grand poobah of how we try to divide is this version. Okay? And this is the same as saying, okay, in this thing, 3 is the denominator. And now I'm blanking on my words, the divisor and the dividend. I honestly don't remember right now. But suffice to say, rather than writing out 48 circles and batching them into 3s, and for the record, I know, do you like my pans? For the record, that's what is really fun of doing with candy, is you just spill out a bunch and say, okay, batch them into 3s, right? You could take 48 and batch them into 3s and come up with this number, right? So do you remember how to do this? If you're a parent, if you're a child, then you just do it with me. You ask yourself, because we're base 10, I'm going to zip back down again, it's just easier. All right, ready? Bye. It's like the elevator. Ah, bye, bye, bye. Okay, all right. So you ask yourself, how many times does 3 go into 4 without going over? It's like the Price is Right. Well, 3 goes in 1 time, right? Then you say, well, how many did I take out of the 4 column? Well, 1 times 3 is 3. So I took 3 away from the tens column, where the 4 is, and I subtract that, and I get 4 minus 3 is 1. Do you remember doing this? Then I carry this down, because I know I've already completed as much as I can for this. So the next thing is going to go in the next decimal column down. And we're going to have a long video, next one, about long division. Okay? Now, how many times does 3 go into 18 without going over? And again, this is knowing your times tables so you can know it quickly. Well, 3 goes into 18 6 times. You put the 6 up here. 3 times 6 is 18. 18 minus 18 is 0. That means you've reached the end. 48 divided by 3 is 16. Or you could say 48 divided by 3 is 16. Okay? Now, if you were to spill out 48 Skittles onto a table with your child and say, let's batch them into groups of 3, you will have 16 batches. Okay? 48 is actually a great number because there's so many of them, but it's kind of funny. You can batch it in 4s. You can batch it in 6s. I'm trying to think of all the factors of 48. There's a lot. So you can just keep switching and realizing, and then you can pick a number like 5 where it's not going to be even, and you'll understand this fractional part left over. It's a really great activity for really any age, because I've noticed that even like teenagers love doing it. So those are the forms of division. We're right at 9 minutes. We're going to do long division. No, next lesson we're going to convert from fraction to decimal and decimal back to fraction, and then we're going to do long division. Okay? And then we'll finally get into some, whatever. All right, have a good one. Stay safe.